Okay, here's another example from rewrite exponential expressions. And so we're supposed to find the value a when we rewrite this expression in terms of something, an a times 5/2 to the x power. So really, we're just all these is not you're not trying to solve anything. You're just trying to rewrite the expression in a certain way, the way that they're asking us to do. Okay, so here's my little solution for that. Okay. Um, Now, the first thing I do when I look at this, what tips me off, first of all, we got fractions in here, exponents and everything, but fundamentally, this is just the left side is two things being added together, and then the right side, what we want to make it into is two things multiplied together. And that's exactly what factoring does. If you think about how, like this basic example of factoring, how factoring has changed this thing that's three things being added up into the product of two things. Okay, so when you want the fundamental architecture of an expression to change from addition or subtraction into multiplication, you factor. So that's the first thing I'm thinking. And a good thing to remember is to what factoring out of GCF looks like. So I just put this little example here: 3x to the fourth minus x squared. I just look for the greatest common factor of these two things, which happens to be x squared. I pull them out, and what's left here is 3x squared and then minus 1. You see, if I pull x squared out of this, I wind up with 3x squared. If I pull x squared out of x squared, I just wind up with a 1. Okay, and you see that it's changed the fundamental architecture from a subtraction of two things on the left side to the multiplication of two things on the right side. Okay. So now looking at this expression, I'm saying, well, 5/2 to the x is in both terms. So I'm going to pull that out. And when I pull out 5/2 to the x power, I'm left with a 1 after I pull it all out of here, right? This becomes 1. And this, after I pull 5/2 to the x out, is just 5/2 to the third power. And you might be like, what? But remember, if I was going to, it's usually like if you can go in reverse, it's a little bit clearer. If I was going to distribute this through, like 5/2 to the x times 1 would be 5/2 to the x. And then 5/2 to the x times 5/2 to the third. Those two things have the same base. I'm multiplying them together, so I'm going to add the exponents. That's why this x gets added to this 3. Okay. I know it's tough to see it going the other way, and that takes some kind of vision and a lot of experience with problems. So that's what I've got so far. And this last step, this multiplication is already here, but I put this in to kind of really emphasize what we've got going on here. And where are we in terms of where we want to be? So we've got this 5/2 to the x times this stuff, and we want to have something times 5/2 to the x. Okay. First thing I can do is to make it look more like the right side, I can just flip this around. Multiplication is commutative; it can spin, so it doesn't matter whether I multiply 3 times 2 or 2 times 3; it's still the same thing. So I just have reversed the sides that these two things are on with respect to this multiplication, and it makes it look more like the place I want to go. Which helps me also realize that this stuff right here, 1 plus 5/2 to the third, is really what my question mark is, right? This is the stuff that's going to be my question mark. So at this point, I just simply need to simplify that stuff. So 1 plus 5/2 to the third power, I'm just going to do the exponent first. And this is just one of those basic exponent rules. If you exponentiate your fraction, it's the same as raising both the numerator and denominator to that exponent. So this is really 1 plus 5 to the third over 2 times third, 2 to the third. And over here, so I've just got 125 over 8 when I do those exponents. Then I just need to turn the 1 into a denominator 8, so I can add them together. I get 133 over 8. And so that's going to be my question mark here. Okay, I've run out of time for this video. My little screen recorder is telling me I don't have any more time. But yeah, that's the answer.